All right, let's start by having a conversation about length, mass, and time. Now, chances are you already know what length, mass, and time are, or you have some general idea of length, mass, and time, but this is a really good place to start getting a foundation in physics, and we just want to make sure we're all on the same page on these three items right here before we start jumping into really complex items. So length, we'll just say that's L for right now. There's a bunch of different ways to report lengths. We know that there are inches, centimeters, feet, miles, and even kilometers. Now, there's a lot of other ways to measure a length also, but the scientific way to represent a length, or we might call it the SI way to represent length, is the meter. And we usually use a little m to represent the meter. Now, a couple examples of how you can represent a length in meters. You would say simply 5 meters, or you could say something like 0.25 meters. Those are just two examples of how you would put a number with a unit to show a scientific measurement. So if it's 5 meters, you say 5. If it's less than 1, you start using decimals or maybe fractions to represent that distance or that length. Now let's start talking about mass. Mass is one of the things that sometimes gets a little confused in the general world. A lot of people will say mass can be pounds. Here in America, at least, some people will say mass is pounds. That's not the case, actually. That's not a unit of mass. That's actually a unit of force, and we'll talk about force later, but pounds is not a unit of mass. Mass is really just how much stuff something is made of, how many molecules are put together to create something, to create matter. Pounds is a combination of mass and gravity, actually. So what is the unit for mass then? Well, there's a couple different ones. One that you're probably not familiar with is called the slug. That's actually the unit of mass for pounds. So pounds is slugs and gravity combined. But one that you're probably more familiar with would be grams. Grams is one way to represent the mass of an object. Now, the scientific way to represent mass, or I should say the SI way to represent it, is the kilogram. And we represent that with a kg. Now, kilo means 1,000, so a kilogram means 1,000 grams. A couple examples of how you would report a kilogram would be, maybe 50 kilograms, or you can even say something like 0.0025 kilograms. And last but not least, we'll talk about time. Time is, kind of a strange thing to think about when you really think about it deeply, but we know that time can be measured in days. We can measure it in hours. We can measure it in minutes. We can measure it in years, months, weeks, so on. But the scientific way to represent time, so the SI way for representing time, is the second. So we'll use seconds to represent time with the unit S, or the letter S to represent the units. And a couple examples that you could say would obviously be just any number with seconds after it. So you could say like 50 seconds, or you could say something as small as 0.1 seconds. Okay, so why are we talking about length, mass, and time, and why do we start talking about this to make sure we're all on the same page with this? Well, it's actually very simple. All physical quantities can be constructed from these three items right here: length, mass, and time. Everything in physics is built off of these three things. When we start off talking about speed or we start talking about velocity, you'll find that it is just a length divided by a time. So it's a combination of these two items right here. Now, what if we start talking about acceleration? When we get a little more advanced and we get into our acceleration topics, well, acceleration is really just a length divided by a time squared. So it's once again just a combination of length and time, except now the time is squared. So if we're not on the same page with length and time, then our accelerations are going to be off and we might be measuring it differently. And it's really important that we're all working together on this. The next thing you're going to learn about would be force. And you'll find out that force is really a mass times a length divided by a time squared. So it's a combination of all three of these right here. So at that point, we'll be into a little bit more of a complex subject, and we're bringing mass into it. And then finally, what about energy? Well, energy is really just a mass times a length divided by a time where both of them are squared. So everything that we're going to learn, and we're going to learn more than just those four things. There's a lot of stuff, and I just brought those four out as an example. Everything that we're going to learn is based on these three items. And if we can get those three items under control, then we can continue moving on. But like I said, we just want to make sure that our SI units are all the same. One of the important things that we need to remember about this when we're talking about our SI units, usually our answers are going to be in some form of meter, kilogram, or seconds, or when we do our calculations, we're typically wanting them in meters, kilograms, or seconds. Now, that doesn't mean I will never ask you a question and want you to report it in centimeters. I might do that. There might be a situation where you don't have to convert a gram to a kilogram. You might be able to just solve the problem with grams. But typically, we're going to use meters, kilograms, and seconds as our base units for most problems.